Okay, good afternoon. Yeah, my audible my voice. Hello. Okay. Yeah. Okay. Last class we discussed. I'm reconnecting my voice. Yeah. Yeah. Now we are going to discussing about what is GPS, the importance of GPS while we are collecting the data in a ground state. Last class we discussed the GPS system, only just definition we have discussed. The global positioning system, it is working on satellite based. So it is only the system today able to show our exact position on where we are stand on at any time, any where or any weather. So based on that, the United States Defense Department was introduced in 1970, which provides in item in the three uses. Sorry. Yeah, unable to share with this. Okay. It's a define the position, latitude, longitude, and height. The velocity, it is a known from velocity from north to south and east to west. Along with that one, we will see the time. It is also it is a universal time coordinated system. So sometimes we see it is known as a PVT, position, velocity, and time. The system, it is typically delivering the locations within a 10 meters accuracy. It is maintaining. So the exact position where we have stand on at our where we are getting the data from there onwards, which is getting the information. So there are three parts are there in a GPS. One, it is a depend on the satellite data, and second one, it is receivers. Third one, it is a software. It's a depend on software. Based on that, it will be working. So uh, actually, it is made by the Global Navigation Satellite System, which was developed by the United States Department of Defense. Only one fully functional GNSS in the world. GNSS means Global Navigation Satellite System. and which is managed and workable by the United States Air Force 50th Space Wing. And the handset, whatever we are observing or identifying, that is not a GPS. Only GPS, it is working as a receiver. The other similar systems also we are having. One, it is Russian GLONASS. It is incomplete in 2008. And one more, it is a European Galileo position system, which is also now already it's working. And Chinese, they are using compass navigation system. Now it's working, and we are using our Indian IRNSS, Indian remote sensing natural satellite system we are using. Then what is the importance of a time? The time has been a limiting for a factor, a lot of science to find out all these things. So that the time it is managing by the position of objectives on Earth. Shift in the clocks, so which is used by the John Harrison in 18th century. So we require while it is navigating from one place to the another place, we definitely it's required to us better and accuracy time. So better and accuracy required time we need. So for that purpose, the time factor is very important to us. Okay, when they were launched the GPS, the first satellite was launched in 1978. After that, slowly the development was started. We were used 24 satellites in mid of 1990s. Now we are using the approximately 28 satellites, not only 28, now we are using approximately 64 satellites. So based on this satellite navigation, the information getting, we are getting the information. So the fundamental change, it is that how the position it is done, and the position how it is going to be changes. For what for that purpose, GPS what it is going to do for us. So satellites, based on the satellites, there are quite a number of satellites out of there in a space. Yes, we have a number of satellites in a space. They are used for a wide range of purpose. Yes, we know that there are various types of satellites there, and we can use these satellites for different purposes. Like satellite TVs, lab phones, military purpose, and cartographic purpose. So many fundamental things and applications will be applied to depend on that satellite usages. These satellites can also be used by GPS receivers also. So the GPS receivers which are working depend on their satellite momentum and the satellite extra whatever satellite data it is extracting. The GPS satellites. Now see the GPS operational constellation, which consists of 24 satellites. Yeah, now it's 24, 29, now 32, and 64 satellites, which orbits the Earth in every precise orbit twice in a day. GPS satellites emits the continuous navigation signals. Yes, definitely, which is emits the continuously navigation signals. So once we are using these satellite signals based on our location, and to identify the perfect locations or exact location where we are stand on Earth. Yeah, receivers and satellites. GPS units are made to communicate with the GPS satellites. Yes, definitely. These GPS satellites, these GPS satellites, which are releasing the data onto the surface or Earth, and the receivers which are absorb or extract the data with signals, and where we are exact position we need to find out based on the scales. So here we will follow the global scales. We'll follow the global scales. As per that scales, and we need to measure the things. Yeah, GPS receiver, it is look like as a antenna. You see here, it is it look like as an antenna, and the first face, front face, you see here, it look like that this it has a display, and down you can see some buttons are there. Some buttons are there. The button which are used for to the display. I will try and I will move to up and down. It's useful to move up and down. So that I'll explain you detailedly later, and just we go into the GPS signals, how they are extracting the data or receiving the data. Just we see that. Yeah, each GPS satellite transmits the data, which indicates its location and current time also. Yes, previously what I told you, the position, it is known as the particular location, and the time also, it is indicating the time also, and it is absorbing and it's giving the information in a particular time and particular location where we have extracted or where we have collected the data. As per that, we will collect the data and we'll find out the time also. So almost all GPS satellites synchronize operations, so that these repeating signals are transmitted at the same instant. Yes, immediately at the same time, the operations will be done, and the signals which are repeating and converting into the codes, converting into the codes. So physically, the signal is just a complicated digital code. So that in other words, we see those complicated sequence on and off pulses which are having. So when it is moving or while we are moving on Earth, the locations will be changes from one place to the another places. So that automatically the location changes will be also displaying or showing on a display. While it is moving from one place to the another place, the time it is also indicating on a display. So there are some system segments also which is having. One, it is the space segment. The space segment it's consisting of a constellation of a spacecraft and as well as the broadcasting system also. So what purpose these? It is useful for to determine the or to find out the exact location, to find out the exact location and the velocity, and at the same time it is showing the time also. Time also. Sometimes maybe it is not showing the exact position, depend on the receivingness of signals. So at least minimum 5 to 7 meters error which is showing. And second one, it is a control segment. The control segment, which is consisting of the facilities, yeah, it is providing some facilities for a satellite. Well, whether it is a monitoring correct, the satellite monitoring, whether it is correct or not, it is showing, and which is useful for the tracking of a location also. It is useful for to move the while we are moving on a tracking, it will be showing. So user segment, what are these user segment? The part of a GPS system which maintain almost all, which is consisting the space control and space and the control segments which are being largely transparent, and the operations of navigation function. It is depend on their navigation functions. Now, what is used? There are wide applications. Wide applications it's required for us to identify the new things and to identify the accuracy, to find out the accuracy results, and those results are reliability, and which is useful for to transfer the data and again the same data, whether it is a processing in the form of algorithms. There are various applications maybe you we may be applied. So it has some signals also. Yeah, there are two types of signals we see almost. Okay, later onwards it was updated depending on their frequency. The waves up to previously it was divided only two frequencies L1 and L2. Later it was updated based on that radio frequencies or radio frequency waves up to L5, L1, L2, L3, L4, and L5. L1, which is showing that megahertz 1575.42. It's a mixing of a navigation message. It's a course acquisition code and encrypted precision PY code it will be showing, and inclusion of new L1C, new L1C. Uh, it will be applicable for further third type of satellites. So that second stage, when you come into the second stage, L2, the frequency it is which is mentioning 1227.60 megahertz P by 4 plus, and the new L2C code on IIRM, and which is useful for use newer satellites also. The next L3, L band 3, we know that we call that is L band 3, 1381.05 megahertz. It is used by the nuclear detonation unit. We'll call that is also detection system payload to signal which is detecting the nuclear detonations, and as well as other high energy infrared events. So for sometimes which is useful for to find out the nuclear tests also, and particularly which is useful for NT BTs. NTBT means nuclear test ban rate. And next one it is L4. The frequency it is mentioned as 1379.913 megahertz. It's being studied for external ionospheric corrections. And finally, it is 1176.45 megahertz. It is known as L5 band, and for use of civilian and safety of life signal. So they are useful to extracting the data in various times, in various types also. Yeah, is there any time differentiation or definitely we see the time differentiation also. The GPS receiver compares the time. The time was transmitted by a satellite with the time when it was received. Now, what we define the time differences, which is explain the GPS receiver, how far away the satellite it is. where the satellite it is locating, and what it is the satellite momentum. So these studies will carried out with using of this time differentiation. Yeah, here we'll use calculating the distance. The distance it is equal to velocity into time. The velocity we'll see that is depend on there. The radio waves which are travel at the speed of a light, roughly 1,80,000 miles per second. Suppose if it is took the 0.06 second within a fraction of that one to receive a signal transmitted by a satellite, now which is floating directly overhead, then we'll use this formula to find out the distance from the satellite, so that now we can multiply second 1,86,000 into 0.06 second. So now the distance we easily to find out with this one. Now we can say that is as the distance we'll see in a miles, 11,160 miles the distance. So this is only just example how to find out the distance. Yeah, we will follow the triangulation principle here, the geometric principle. Based on this, we can find out the one location. If you know, it's a distance from one to the another and another. So now you can use that one 536 miles, 536 miles into whatever seconds travel. Now you can multiply with that one, you will get it. Whether if it is a one satellite or sometimes we may find out the distance between the two satellites, and third three satellites, the distance from one satellite to the another, from one to second, one to third. Based on that, the principle we can easily to identify that specific point. So you can see here multiple first satellite. I mean one satellite when we use in a 3D trilateration. We see here the first satellite, second, and the third. I mean three satellites where and more than three also we can see. Yeah, there are some automatic clocks also we have atomic clocks. GPS satellites which use atomic clocks, which are used for to find out the accuracy data. And but if we can use that, definitely we get the exactly position and the exact data. But whereas which are having the very expensive and very cost compared with other GPS clocks and receivers. Yeah, here the line of sight and which is a transmission. We see here line of a sight, it is the ability to draw a straight line between two objects without any interference of other object and which is getting the way. Yeah, in the first case, you see here there is no line particular position. We are unable to draw that line because of something interaction or interfere or introduced here. So the light it is not restriction by this GPS. So that we are unable to get. So just example for you can see in a cloudy season. In a cloudy season, sometimes you can see in hill areas, in particular the cloudy seasons, because of the clouds are interrupters there. So the abrupting the these clouds are abrupting the receiving of signals where the satellites were release the signals, but at the time the clouds were abrupting or creating the disturbance between to the satellite, so that we are unable to get the signals. I mean, it is not received by the GPS, so we are unable to draw a line, so that the data it is also not transmittable. Then now you can see here in the second position of this picture, the satellite where the satellite it was positioned somewhere, and it is releasing the signals from to the surface, so that now there is no interaction between the satellite and as well as the GPS. So the straight line, I mean, and the data it will be it is really receiving by the GPS. So some of the obstructions are some of the interference or nice data which are creating, and which were in the presence of that we are unable to get the data, or we are unable to receive the data with disturbances more. So if you wanted to take a data mass, you have to check the atmosphere conditions, and we didn't get any disturbances. Then only we will get the data very clearly. Otherwise, we are unable to get the information from the satellite signals. Yes, sometimes we see the light of a refraction, like these light of reflection also we see in this principle of GPS working. So what is happening? Sometimes the GPS signals from the satellite doesn't follow the straight line because of it has a refraction method, or it is a different and the refraction principle. The refraction, we know that it is a bending of the light as it travels through the one media to the another media. So here, in this case also, the signal it is also getting the refraction. How it is getting the refraction? Yes, we know that the above the surface of the Earth we have some stratosphere, troposphere, mesosphere, ionosphere, exosphere, like these spheres we have. So signals were released from the satellites, which is a release from the satellite. So it can be like a light when they hit some interference like air patterns in the atmosphere. Sometimes maybe the climate as the conditions also it is not supported to that to that. So there, what is happening? The waves are signals which are not move in a straight line. So automatically, which are getting in a diffraction mode. Sometimes we may call it's a bend line, or a curved line will be forming instead of the straight line. So that little bit the line it is going to be bent. So automatically the signals which are not are transmitted or transported to the surface where we are collecting the or where we have stand on the surface with using handling of a GPS. So at the time we didn't get the perfect signals, receiving of the signals, and at the same time it doesn't show the any results to us. So here a signal interference. Sometimes the signals may be bounce off the things before they have hit the receivers. Yes, this I told you in a offline class, the refraction mode that we have seen, the rays whenever it is a fall on an object, some of the objects which are receiving or absorbing the radiation, and a little amount it will be reflecting. Yes, similarly here also the signals wherever the signals which are released from the satellite, sometimes maybe it is unable to extract, receive, unable to receive. So because of it is getting the disturbances and some obstructions will be there. So that is the reason we are unable to get sometimes. So that's what is happening. The signals may get bounce. Yeah, satellite distribution. In a satellite distribution, when the satellites are in all the same part of the sky, in the same part of the sky, and why they are rotating. Uh, yes, then what will be happen? So here, what is happening at the same time? All the satellites which are releasing to the data in a vertical mode or straight onto the surface. At the time, we are unable to get accuracy data. So the data maybe is less accuracy. It has a less accuracy. So single satellite, if it will be there, then automatically it will be covered very less area, and it will cover very less area, and the more accuracy data we will get. Yeah, precision dilution of precision. Yes, here it is. You see here the same distance which are mentioned by the different satellites, where the man was stand here between the two hills, or maybe was stand here in the valley. So you can see we will get the different obstructions we'll see. Almost all of these combines to make the signal very less accurate, because of all they are releasing at a time, and all they are for all the satellites are focusing at a, one point. So what is happening? The distance depend on that the distance, and the releasing of releasing of radiations onto the object. Maybe it is less depend on their depend on their intensity of those waves. Here sometimes we see you see the right side of this satellite. It is also showing the 11,000 miles, but the receiver unable to get it. And the second one you see here a little bit bend. Little bit bend means sometimes maybe something here obstruct but there. Then again the straight line, it is also you can see here, and it's also the distance it is maintained same 11,000 miles. And again here also little curve was there, but we will get it is covering very less area, and as well as the more accuracy we will get it. We will get it the more accuracy. So that can depend on the intensity of that one. A PDOP means positional direction of a precision. Maybe it is a less than it is excellent. Sometimes maybe it is a 4 to 8 distance that is looked as a good, or above the 8. Sometimes maybe above the 8 it is known as a poor quality. Differential corrections, differential positions, differential positions. The differential correction, it is a technique we will use greatly increase the accuracy on whatever collected the GPS data. Then which involves to using the receiver in a known location particularly. So sometimes what is happening, we have to collect the data from the unknown locations also, unknown locations. So based at the time, base station it is required. That means a ground station data or a ground truth data or a reference data it is required on a particular unknown areas. So if you know that in known areas, every location pinpoint, we have an idea. Then yes, according to that, we will collect the data. So if you go into the unknown areas, particularly unknown location, unknown locations, so that at the time directly we will have a contact with a particular area, then we'll collect the data accuracy. Yeah, here post processing. Once you have a collected data from different locations or different areas, so what we will do? whether the area, if it is that area, if you have an idea, the reference data must show. Then now we have to compare with that location whether it is the correct or not. Location whether it is correct or not. Based on that signals or what we have received the data or what we have collected data from a particular location, we have to do the processing. How GPS it will be working? Yes, the GPS it will be working by the triangulation method, or yeah, triangulation method. The distance must we have to measure how long distance we are mentioning from the signals where we have a located on a particular location. The distance must and should we have to calculate it. Then only we will get the accuracy position in a particular area. Yeah, coming to the latitude and longitude, what what does it indicating the latitude and longitude? Yeah, latitude and longitude are spherical coordinates on the surface of a Earth. Latitude is giving the information from north to the south, or the north or the south of the equator position. So latitude always it's giving the information from a north position, from a north position. I'll show you an example of a map also. Longitude, it is always showing or giving the information about the east or west from a Greenwich line. The GPS, which is useful to us to find out the where the exact position, and it's also useful for to reference for different locations based on the ground truth data. You see here the equator, somewhere here it is showing the equator above such area it is known as north, and the equator line below that it is known as the southern position, and here prime meridian line was indicated, and yeah, it is dividing into the two parts in the east and the western part of the area, so that the north, so that it is indicating as a yeah, see, this is indicating as a north and south line. See, now you can divide like this. This position, the straight or vertical line, it is indicating as a north. So north and south. It's southern position. Now this side, the west and the east. West. It's east. The latitude and longitudes, which is indicating, see from here, it's not always it's showing the latitude values. Then whereas you come into the longitude, it's showing the east to west direction. So sometimes you may measure the directions from north to east also. South to east also. So based on this, we can measure the lat and the longitudes. Okay, on a display, we have a display in a GPS. Okay, once if you can on the display with using the power of button. Yeah, you see here, there are various types of companies which are providing the GPSs. Yeah, it is an antenna. It is antenna. Actually, the old GPS are having like this antenna. Now it is a power on and off button. Which one? Then we go into the mode. Different modes. It will be displayed on a screen. Then once uh, the satellite signals will be appear on a screen. So based on that, the satellite signals, it will taking for some time to extracting the data for a particular location where we were stand, and it will be showing. It will be showing the signal locations, and it's giving the latitude and the longitude information, north and east. Later that, from one point to the another point, it will be showing the way also. So the way it is known as a waypoint. Suppose you see here one point you have to pick up. Somewhere you have taken one location here. Now we wanted to take another position somewhere. Now you can create the waypoint where it will be showing the way also to us from one position to the or one location to the another location. So based on that location, we will move. While we are moving, it is tracking. It will be creating the track on a display. So now you can catch that track. You can walk along the track, and you reach that second point. You reach that second point to collect the sample or reference data, whatever it is that. So now it will be showing on a display. It will be showing on a display. So once you demarcating or once you are collecting the data, it will be stored. It has a capacity depend on the usage of GPS. There are various types of the GPS we have in a market. So it has a systems. Systems means units. So the GPS, sorry, the latitude and the longitude data, which is converting from one units to the another unit system. Suppose it will be showing the data sometimes the position of a location. So I'll show you. Wait. Okay, now it is a live. I'm unable to share with another one. Unable to. Yeah. Okay, sorry. I wanted to show you, but another thing, but I'm unable to. It is stopping. Not unable. It is sharing this page. I show you something later. Maps. I want. Yes, right. Oh, okay, now you see here one map. Yeah, just you see here. Yeah, it is indicating some values on the left side of a map. 78 degrees and 45 minutes. It's showing the 45 minutes. The line, the small. Yeah. Okay. 78 degrees 45 minutes. It's a longitude. It is indicating the longitude. It is indicating the vertical line. It is indicating the vertical line. Then again, the 19 degrees 15 minutes. It's showing the north values. It's a latitude values. It's a latitude values. So there is a differentiation. Yes, yes. There is a differentiation from 78 degrees to 45 minutes. Then after 5 minutes, that means from here, from somewhere, the location somewhere you have a collect the sample, and from here to here, here to here, it is mentioning the 5 minutes distance from here to here, 5 minutes. So 78 degrees 50 minutes, 78 degrees 50 minutes, and some seconds also we will see. So this is one type of a unit system, degrees, minutes, and seconds. Second. So I wanted to convert these degrees, minutes, and seconds. Yeah, these values we can convert into the uh, decimal system. Decimal system. So for that, there is some principle for that one. So how we can change it? We can change on the GPS. So the system option we have, unit system option we have, and at the same time, compass in which direction we are moving on a field or on a earth. It's also showing by the GPS. So, and what is the speed we are walking on? We are walking on a surface or on a earth. The speed it is also showing, and as well as it is showing the scales also, map scales also it is showing, and depend on our requirement we will fix the scale while we are mapping the scale. Suppose you see here the scale, here it's a, here it is showing that the map refer the map scale, it is 1 is to 50,000. 1 is to 50,000. Later I'll tell you 1 is to what it is, a 1 is to 50,000. So now coming to the, this is okay. Now coming to the second point, here in north direction, I told you not always it is showing as a latitude values, and the longitude values showing the east direction, east, from east to west, and north to south direction, which is shown by the latitude. So these are all we can identify on a GPS. So based on that GPS values or latitude and the longitude values, we need to identify the morphological features locations on the surface. Now we, yeah. Next, what are the components in a GPS receiver? Yeah, in a GPS receiver, it has an antenna and pre-amplifier. What is use of what is the use of pre-amplifier or antenna? It look like as a dish. It look like as a TV dish, which is receiving the information. Whatever satellite it's whatever satellite it is. Okay. Sorry. Whatever satellite it is releasing the information onto the surface, the receiver or a cap type or a cup like or dish type objects which are receiving the information, it is known as an antenna. One more compartment it has that is known as the radio frequency section. The radio frequency section, again we know that it is as a computer processor. It has a signaling processing in the form of electronics. It has some electronic chips. It is receiving the data and it will be converting into the computer's code language. Second one, it is a control unit interface. The control unit interface, which is interacting with the microprocessor, depend on their sizes. It will be receiving the data in a huge amount, and at the same time, it will be sent to the data into the display system of a satellite. some devices are having the recording devices. I mean, some GPS are having the recording devices. Whatever the data we have collected, it will be stored in their memory. Some depend on that capability of GPS. The younger generation of the GPS are having the more capable the data or store the data in their memory. In older or medium RAM of GPS are having the store the capable data up to 1,000 locations of a point, and every point it will be creating the waypoints also. Waypoints. Waypoints, it is known as it will be showing the way from one point to the another point. Map is also created. Map it is also created in that update in a updated GPS. One more thing, it is a power supply. Yeah, the power supply is the depend on some of the power supply, like what we are using our mobile charges, like those mobile charges we will use to charging the GPS, depend on their battery capability, or some of the GPSs are having the battery systems. We'll use a normal wall clock batteries. What we are using, the same batteries we will insert into the GPS compartment, battery compartment, and in the current which is transmitting from AC to the DC. So that as per that depend on that capability of battery sizes, the GPSs will be working. So there are a number of power sources which are having data dictionary. Here, a data dictionary means the GPS units which collect the data in the form of a points, lines, or areas, whatever it is that. Points, we know that a raster form of a data we will collect it. And second one, it is lines. Lines, maybe it is a group of points which are create the lines, and as well as areas. The areas which is showing the closed polygons. Polygons, and these are only known as a features. A data dictionary, you can define that what we collect the data in a specific information about the particular feature or a particular ground truth data what we are collecting. According to that, we will save or we will preserve the data in a GPS. Okay, this is about GPS. Sometimes maybe the GPS it is asking as a short question. And next we see the next lesson. GIS database creation. How we will create the database depend on the GIS data models. I told you there are various types of data we will use depend on our requirements. Depend on our requirement, the data which is created by us. The GIS data we may use broadly into two types of a data. One, it is a spatial, and second one, it is a non-spatial data. In non-spatial data, in another word, we will call that is as a attribute data. The spatial data, it is known as related to the geospatial or geographical data what we will use by the we will using by the coordinate system. Okay. So suppose if you collected the data from different locations, those locations must have a longitude and the latitude information. Along with that one, geomorphological features also we need to identify, and as well as the spatial data we can uh, transfer from the remote sensing images or topographical images, and what we are collected the data from field, the GPS locations also we need to collect, and as well as the data we should have to convert into the different models depend on our requirement. Here the GIS data models, geographically the data information we should convert into the system. The system which is having the GIS tool, and it should be supported to whatever data we have uploaded into the system or in your computer. So here there are two types of data models we will consider. One, it is a raster data models, and second one, it is a vector data models. Now we will see the what it is. First of all, database, how you are going to create. That's important. There are some examples given here. It is like example phone book. What we are going to create. Telephone book contains it has the information for all the locations and addresses also. Airline reservation system. Airline reservation system it contains the geographical features and motor vehicle system record. One more example for papers in your filling filing paper filing cabinet and files on your computer hard drive. These are all the example to create the data what you are going to creating or update the things. How we can define that? Database means it is a organized collection of data. What you are going to collecting data from your field, it will be organized in a systematic way as per methodology or as per the process. So that is depend on manually if you are collecting. So at the time, no need of a computer based system. So what we will do that for that? We will follow the data management system. So what it is that data management system? Data management system, it is again, it is association with the software now. So on a database, only we have collected the data in the form of a, whether it is a raster data or vector data. In a raster data, the data may be we see into the different grid styles or a grid pattern data, what we have collected the data from a ground. In the last class, I explained that. I explained. Suppose if you are creating the map, if you are creating the map, then there are some points will be created on a sheet. Those points we will consider, and it is a group of points are going to be created as a grid system. So each grid point or each grid it contains own location. So it is a considered the specific point whatever you have identified on a grid. It is on a ground data or a object, whatever object which is arranged on the ground. So point it is indicating whatever point you have identified on a grid, it has a own location. It has a own location and it is in the form of point. It is in the form of point. The x coordinate value and as well as y coordinate value. So both where they were intersected, they created one point. The point it has a location. The location it is indicating the specific object, whatever situated or whatever located on the earth surface. So according to that, we will find out the object on a surface based on the raster points, based on the raster point. So here, the major use the raster data. It is useful for to creating the map. It is useful for to creating the map. Map means here it is a combination of the raster data and as well as a vector data. So here we are going to creating the data. We are going to creating data based on the ground truth in a digital mode. Digital mode. So finally we will convert into the digital images. So here it has some color cells also. Those color cells are known as a pixels. Those color cells known as a pixels. So okay, later we discuss that. So it is definitely it should be supported with the software. So what we will do for that software, we will do the organized or we will systematically arrange the data, whatever text flexible to us. And one more thing, it is the data management system which is provides the tool to add, modify, or to delete data from the database. And also it is inquires the query of the data and it's giving the caution wherever it has any queries in the data. It's giving the cautions to us. And finally, it is producing the reports to summarizing all the selected points or selected contents what we have summarized with the using of previous data or depend on the previous data or modified data. So what it is our ultimate purpose, what we will do with a database management system. We'll enter the data and the data it should be giving the information and the information we'll get based on that information we'll get some knowledge about that object. So finally the result we will get it. Based on that result we will take certain actions. So first we need to collect the data, we need to enter the data, then it is giving the information and it's creating the information or a source. Finally we'll get some knowledge. Based on that knowledge, we will get output or a result and we'll take certain action. What are the features are having the data management system? The database management system provides the following features to maintain the database. The data, it should be independence. So what it is the use of independence data if we have? Yes, it is referring the whatever locations data you have in our hand. That's depend on our applications to make a changes in the definition and to organization of a data. Integrity and security, which refers to maintaining and assuring the accuracy and consistency of data over its entire life cycle. Yes, once if you are modified the data or the ground truth data, it will be useful as a refer to us. Until you complete that work, it should be useful to us. The entire whatever work till completion of that one, the reference data it should be useful to us. Transaction and management. Here, a transaction comprises a unit of a work performed with based on the data management system, which is again is on a database and which is treated in a coherent and reliable way. Yes, must and should. We can treat or we can use the data if it is a very reliable. Yeah, the transactions in a database environment have a two main purpose. One, it is to provide the isolation from other transactions and to have an all or nothing effect. Yeah, concurrency control, which ensures that corrects the result whatever data we uh, get it, and the concurrent operations are generated while getting those results are quickly, whether it is possible or not. It has a backup and the recovery also, and will provide the languages creation. Whatever data, if it has some data queries, we need to solve the queries. And again, it's a depend on their language writing for application programs. This is also one of the basic feature. How to select the data management system. The data management system, it can be divided into the two categories. One, it is the data desktop database. It is a personal or single user applications. Second one, it is a server based. Yeah, the server based actually more than one person will use, and multi applications also will be done here. Relational database. The relational database model is the most dominant model in both corporate and JS world particularly. Yeah, it was defined by the Edgar F. Ford in 1970. It can be accommodate a wide range of data types. No need to know the before hand type of processing that will be performed on the database. There are some attributes while we are creating the table, which require some attributes, and attributes are fields. So we need to explain or we need to fill with the ground truth data, then only it will be creating the attributes, different types of attributes, and it's related with the case. Yeah, attributes. An entity, it is represented by the set of attributes. That means here whatever raster and value raster and vector data we will use in a data management system. It is going to be creating as attributes, different types of attributes. Those attributes may be sometimes it is a simple or sometimes maybe a composite attributes will be created. Yeah, single value and multi-valued attributes will be also created depending on their multi-valued data when we applied. Based on that, different types of attributes created. It is a relational database terminology here. The basic characters we use in a bytes. Next, we will enter into the fields, attribute or columns, what we will data we will enter, and which is going to be created in the table mode. And next, it's converting into the records. Records will maintain, and then files will be also created, and finally those files, so we group of a files which is related to the one to another, then the database it's a creating, yeah, keys. And here there are various types of keys we use. Super key and candidate key and uh, foreign keys also we use. A super key it is an entity set. It is one or more attributes we use. That means more functions we need to work out. Second one it is candidate key. It is a candidate. It is a minimal super key. So here we'll create the single table keys and multi-table keys. So as per that, whatever data we are going to create in a multi-purpose or a single purpose. As per that, these keys are used. Super key. You see here example here. There are some students data is given. Students data have been given here. ID number, roll number, register, names and place and standard. It's a multi-purpose data, so it is used for multi-purpose. So that super key, the super key may used here. Here also same candidates key. Yeah. Yeah, in primary key, in a primary key only we will use ID, single ID we will use. In a second case, yeah, ID, roll number and register. More than two functions will be done. And here number of functions and the number of n number of data will be entered in a super key. Here two or three candidates of information we will get. Here only single information, single user information we will get in the primary key. In a composite key or concatenated key, with a more than one attribute it has. That means multi-purpose data. Multi-purpose data we have. Suppose here one employee ID is one employee ID number. If you can click here, the whole information it is giving. The whole information is giving by this one. One more, it is a foreign key. It is an attributed key of one or more relations other than one into the which is up here. Just example use. A primary key, and again here a primary key it has a foreign key and foreign. One and more information it has. One and more information. Additional information, if you wanted to add with this one, then we'll use this. So how it is useful to us, that's important to us. Yeah, this one. Okay, here the relationship with polygons and as well as or dot or pointed data. So the data, whatever we are going to be converting from the raster to the vector data, the raster data, it contains the pixels colors, different pixel colors or dotted colors we see. So group of dots or group of pixels which is going to be creating a vector model data, which is going to be creating vector model data. So in a raster data, we have a seen only x, y values we see. Whereas we come into the vector data, we can see x, y, z values, three-dimensional values we have in a vector model. Here we can see the lines, whereas we can see the circles, like polygons. We see the rectangular shapes or square shapes. The data we takes in It is available. It is in the form of a different structural model or a different polygonal model. So it is only example. It is given only one student of data we can enter into. It has a ID, name, address, phone, and all those. You know, the student's information. The student's information we can maintain and enroll with this one. Almost enroll with this one. Only one student. It has information, and as well as it is associated with polygon data. It is association with the polygon. So n number of or number of students data we have a chance to create with vectors. The vector data it contain again the commonly we use three types of vector models. One it is a spaghetti model. Second one it is topological model. Third one it is vector chain model. Vector data types also these. The vector data types means like previous. Maybe it is the data which is stored in the formation of the polygons or a group of a points or a lines or a lines. And finally, it is going to be creating as a entity the relationship and the final attribute of a particular object on a image. So yeah, these are all knowledge. All these are all the attributes or data we can create in the form of a tables in a GIS. So here there are some relation with a algebra symbols. The transformation of the data in with the relation operations, intersection, divide, or join. The symbol it is showing like this, and this can be expressed using the different combinations of fundamental operations. Yeah, it is supported by the structured query language. Yes, the data definition language which is used to create the manage the database, and whatever data we have entered, then it should be manipulated so that it is a required the data manipulation language. Yeah, it's known it. Now coming to the spatial data here. The spatial data it has a structure. Yes, the spatial data it has a structure, and that does not necessarily fit with the tabular structure. Sometimes maybe it is a fixed or sometimes not. As per that, to construct this spatial object where it is required the several tables which are joined in the attributes. Spatial indexing is very different from the type of indexing used, whatever relational database. So here, these all the spatial types and the simple features what we will use, like symbols for mention, line, horizontal line, it is showing us a relationship, and triangular it's a type, diamond shape it is showing as a composed. So here based on the symbols, the data whatever it has, we have to explain and we have to recognize. Yeah, once just you see the filing the data, how we can file the data with ground truth data. So here we'll create the arc map or information. There are two. The arc means here the polygons we will create depend on their geographic coordinates. And the information we see that is in the form of attributes. So here there are some files to be created, and that's, The files, it should be created and separated with linked files. Here there are two types of files we see. One, it is coverages in ARC formation, and second one we see that is shape files. Yeah, coverages which were developed for a workstation. It is useful in a ARC and info. It was developed in 1980. It has a complex structure, and it is available in a proprietary format. The attributes were created in the information table. Whereas we come into the shape files, we create the shape files, and we see these are all in a ARC view model. It was developed in 1993. Simple structure it has, and it is easy to understand and easy to create also for public domain purpose. Then the attribute, it is in available in table. Database table. So here the vector data, whereas suppose if you see in a ARC info coverage, in a ARC info coverage, it is an older technology actually. It is a older technology. It has create a relationship between spatial information and as well as attributes. Whereas we go into the shape files, it's the most common native data in the form of ArcGIS. This one. It's based on the geo-based data. The geo-based data, maybe it is useful in the next generation of ArcGIS. Now we are using that. And one more thing, it is a digital line graph method. In a digital line graph method, the USGS file format for vector data, it is replaced by the SDTS, that is known as a spatial data transfer standard. One more formation, it is the tiger. The tiger means topographically integrated geographic encode and referencing. These files containing the geographical information and geographical features like road lines, rivers, lakes, political boundaries, and other census statistical values. These are all will be there. Yeah, which one is the best? Whether the vector or a raster? Vector versus raster, we say. That what are the differentiation between? Yeah, actually we need both type of data. It's required to us. It's required to us. Both we need. In particular, vector, it is a relatively very low data volume and which has a capability very faster display, and also it can store the attribute, low attribute, and I does not indicate how features should look into the GIS. Whereas you see in a raster data, the relatively high data volume and slow display has, and also it has a no attribute information, more pleasing to the eye inherently store how features should be looked into the GIS. So there is a small variation between two, the raster and vector data, but if you wanted to create the vector model data, you must and should we need to depend on the raster ones. Data source and acquisition. The data source and acquisition, whatever data we get from a remote sensing point of view in the form of a different formats, those formats you can convert into the hard copy. Then the hard copy maps, it is from what we are calling the cartographic sources. I mean, Survey of India topographical sources, or maybe it is a air photographic sources. Air photograph means ortho images. The remoting sensory images, that may be Indian remote sensing or cartosat maps, Landsat or spot, or sometimes maybe the data you will immediately release from the digitally, I mean the photographic, or sometimes we may use existing digital data also. So once if you get the data in a hard copy, these are all the source to update the whatever I have collected data from different areas. Depend on these sources, now you are going to update. So how we can update? There are two types of methods we have to update the things. We need to digitize here to edit the things, to edit the object what you have identified on your features on a hard copy. So what we will do for that? We will do the scanning. We'll do the scanning. Then for a manual digitizing, if you wanted to do the manual digitizing, just you take a pencil or whatever it is that you hard copy you put on a plain table, then you can draw what you have identified features. Now, then you can update the old one. That's manual digitizing. Or second one, it is automatic scanning. So you can scan by the scanner, depend on that DPI, depend on that the pixel sizes, dot per inches, how many dots which are having the inch, and the file size also we can define. Depend on that we can define the file size. According to that we see. So what we will do for that? Here, once the data, if you are going to create in the raster format, the digitizing means here it is in the raster format. Then now you convert into the vector conversion. What we will do for that? Whatever you have done the scanned data in a raster format, we should do the vectorized. That means we can convert into the vector. We can convert into the vector. So what we have a scan that we can convert into the digitalized mode. Digitalized mode. So then it is ready to edit the object. Then with using of a GIS format. Now you can store the data in a different format. I told you in a 10th lesson, different formats we have the store of the data in a different format. So according to that, now our GIS, it should be supported to that formats. Now it is ready to usage. Once whatever data you have extracted or collected from the different sources, like in the form of the hard copies, or in the form of the photos, or in the form of the digital images, now you can convert into the vectorization mode. So now you have to do the edit what you have collected the data from the ground source. Based on that ground source, now you can edit the things or objects on a GIS. So now I'm stopping here. We will continue in the next class.